So we went over the similar figures and stuff like that last hour. Now I want to kind of transition just a little bit, and we're going to look at those measurements. We had to convert, guys, stick with me. We had to convert the measurements, feet and inches and stuff, to make some of those calculations, to reduce some of those ratios. And so now we're going to look at working with those measurements just a little bit. Let's say we have, come on, 7 feet 3 inches plus 2 feet 8 inches. Now, just like any other addition, we're going to start on the right and work our way back to the left. Our place values now are no longer ones, tens, and hundreds, but they are feet and inches. So we go ahead and add, start on right. 3 plus 8 is 11. Do we have to carry? No, not until we hit 12 here because of the feet and inches. So 7 feet and 2 feet make 9 feet. Now, of course, it doesn't stay that simple. Never does. Yeah. We can run into something like this. 9 inches plus 11 inches is 20 inches. What do we have to do with that? We have to take 12 inches out of it. Take 1 foot out, and what are we going to be left with? 8 inches. So we're going to keep the 8 inches and carry the 1 foot. Then what? 1 and 6 is 7, plus 5 is 12 feet. And of course, we can work with other units. What do we do here? Not everybody at once. Add the ounces. Okay, 11 and 13 makes 24 ounces. Take out 16. Take out 1 pound, which is 16 ounces, which leaves us with 8 ounces. So carry the 1, 13 pounds and 8 ounces. Very good. How about this one? Oops. 5 gallons, 3 quarts, plus 2 gallons, 2 quarts. Well, 3 quarts and 2 quarts makes 5 quarts. Of course, that is 1 gallon and 1 quart. Very good. So we'll keep the 1 quart and carry the 1 gallon. And then add 1, 5, and 2 add up to 8 gallons. Any questions? You like this stuff a little better? Yeah? Subtraction, same thing. Line up the columns. Place values again in feet and inches. We work right back to the left. 8 minus 5 is 3 inches. 7 minus 4 is 3 feet. Of course, as you've learned by now, it doesn't stay that simple. We might have 8 feet 3 inches minus 2 feet 9 inches. Okay, yeah, 3 inches minus 9 inches can't be done, so you have to borrow from the 8 feet. That's now 7 feet, and this is how much? 15 inches. We borrowed 1 foot, which is 12 whole inches. Now what? We subtract. 15 minus 9 is 6. 7 minus 2, 5 feet. How's about tell me what to do. We're going to have to, 2 minus 15 can't be done, so we do have to borrow from the 8. That's now 7 pounds. What's this become? 18 ounces. 16 ounces in a pound, so 16 plus 2 is 18 ounces. And we subtract. 18 minus 15 is 3 ounces. 7 minus 5 is 2 pounds. How about 3 yards and 1 foot minus 2 yards and 2 feet? Got to borrow. This becomes 2 yards. What's this become? 4 feet. Good. 4 minus 2 is 2 feet, and that's it. 2 minus 2 is 0 yards. Okay, well, let's look at the fun ones. You sound like you don't trust me when I say that. 5 feet 8 inches times 7. Now, some people prefer to just convert them all into inches, but we're going to look at how we can keep them as the dual units and work with them in that way. 7 times 8 is 56 inches. Now, that's going to be more than 1 foot. How many feet can I get out of there? 4 feet would be 48 inches, so how many are left over? 8. So we're going to keep the 8 inches, carry the 4 feet. Now it's 7 times 5 is 35, and then we can add the 4 is 39 feet. Not so bad. So how about this? Well, obviously, we have to do 9 3/4 times 6, which is going to be what? $58.5 inches. Obviously, that can be reduced to how many whole feet? Say 4. 4 feet is how many inches? 48. So there's 10.5 inches left. So keep the 10.5 inches, carry the 4 feet. 6 times 7, 42 plus 4 is 46. Those are the ones that usually get people. Any questions on that? One for you guys to try in your notes. £9, 11 3/8 ounces times 12. Have fun. Yep. We've established this. I'm a math teacher. I'm not really a nice guy. So 12 times 11 and 3/8 is 140, or what? Something's off there. I mean 136 and a half. I think he did times 10 and 3/8 instead of 11 and 3/8. So how many 16s can we get out of there? 7 times 16 is 8 is 128, isn't it? 8 times 16 is how much? 128? Yes. 136 and a half divided by 16 is 8 point blah, blah, blah. Yeah. So the 8 is what we needed. So 8 times 16 is 128. So we can use that to figure out how much is left over. So there's how many left over out of if we take out 128? 8.5 ounces. So what do we do with that? Keep the 8.5 ounces, carry the 8 pounds. Then what? 12 times 9 is 108. Plus 8 is 116. So 116 pounds, 8.5 ounces. What do y'all think? Good stuff? Okay, now let's look at division. If I want to divide these out, some people again would turn this all into inches, divide by 4, and then convert it back, but I'm trying to save the trouble of doing the conversions. Remember, division is the one operation that starts on the left and works back to the right. So let's go ahead and work through that. 4 goes into 27. How many times? 6 times. So that's 6 feet. What's 6 feet times 4? 24 feet. Now to subtract, we've got 3 feet left over. Now before we can bring down the 8, what do we need to do? We need to turn that 3 feet into 36 inches. Now I bring down the 8 with the 36. I have how many inches? 44 inches. Divided by 4 is 11 inches. 6 feet, 11 inches. Try that one quick in your notes. Weird math. So 7 goes into 25. How many times? 3. So that's 3 feet. 3 feet times 7 is 21 feet. These are 4 feet. So now before we can bring down our 1 inch, the 4 feet has to become 48 inches. And now we bring down the 1 inch to make this 49 inches. Divided by 7 is 7. So 3 feet 7 inches. 43 inches if you'd done it that way, but you got to make sure you convert it back down. So how about this one? So 6 goes into 8 how many times? That's 1 pound. Times 6 is 6 pounds. Subtract gives us 2 pounds. Now before we bring down the 12 ounces, we got to turn the 2 pounds into 32 ounces. Now when we bring down the 12 ounces, we have 44 ounces. Divided by 6, 7 1/3. And yes, we can have fractions there in our smallest unit. We don't want any fractions in the first unit, but the smallest unit has to have fractions in it. Now, as we're calculating with our measurements, there will be times, especially if we're doing like a Pythagorean rule or something like that, where we're finding the side of a triangle, where we're going to end up with decimals in our answers. And we might end up with an answer that looks like this. .183 inches. The question is, where's that show up on the tape measure? It doesn't, does it? We don't have .183 inches on the tape measure. So we need to figure out how to convert that into inches and 16ths or 18ths or whatever. Let's say I want it to the 16th. So what we're going to do is we're going to keep the 47. That's 47 whole inches. Remember this from last semester? .183 over 1. What are we going to do to it? Times what? Times 16 over 16, right? The 1 times 16 is 16. .83 is 1.183 times 16 is 2.9. Okay, that's between 2 and 3/16. Which is it closer to? 3. So it's 47 and 3/16 of an inch. Let's say I have 8.717 inches and I want it to the nearest 1/8 inch. Go ahead and try that one for me. See what you come up with. Nice shot. To the 1/8 inch, yes. It's going to be 8 whole inches, 0.717 over 1. Now, realistically, we know we just have to do the 0.717 times 8, right? We know the bottom's going to be 8. What's 0.717 times 8? What is it? 5.7 something? So it's between 5 and 6. It's closest to the 6. Of course, that's going to reduce to 3/4, right? Even though we want it to the nearest 1/8, it's okay to reduce it to 3/4. Look familiar? So I'm going to start out with a rectangle. It's 2 by 5. And I'm going to do this to it. If this side becomes 6 units, what's this side up here have to become? 15. What is that ratio? Yeah, my ratio of lengths The 2 becomes 6, or I could do 5 becomes 15. Either way, it reduces to a 1 to 3 ratio. What's the area of this one? 2 times 5 is 10 units squared. Would this one be 30 then? This ends up being 6 times 15 is 90 units squared. My ratio of areas is 10 to 90, which reduces to 1 to 9. Not the same ratio, is it? The question is there a relationship between them? What's that? What's that? 3 times greater? Well, let's take a look at a different one. Let's look at a square here that is 3 by 3. And we're going to enlarge it to 6 by 6. What's our ratio of lengths? 3 to 6 or a 1 to 2, right? What's the area here? 9. And what's this area? 36. And our ratio of areas is a 9 to 36 or 1 to 4. See a pattern yet? One-third squared, 1 squared is 1, 3 squared is 9. 1/2 squared, 1 squared is 1, 2 squared is 4. It's the ratio of lengths squared. So if I have a figure where I have a known area, and it can be kind of an ugly looking figure like this. So let's say that this figure, I know that this length here is 4 inches. And I know the area of this is 32 inches squared. This figure over here, let's say this gets blown up to be 10 inches. What's its area going to be? Well, the ratio of lengths is what? Yeah, 4 to 10, which reduces to 2 to 5. The ratio of areas, then, we square that. It's going to be 2 squared is 4, 5 squared is 25. Where's the 32 go? On the top. Cross multiply and divide. This is going to become 200, right? Kind of cool, huh? So pretend this piece here is a straight line, and it has a length of 8 feet. And we enlarge it here so that it now has a length of 12 feet. This figure over here has an area of 256 square feet. Find the area of that figure. I'll give you a minute to do that in your note. What's our ratio of lengths? 8 to 12, which reduces to 2 to 3. So then for our ratio of areas, it is what? 4 to 9, right? 2 squared is 4, 3 squared is 9. So then we put in what in here? 256 on top. So is that 576? Does that look right? Let's say we have a cube that is 2 inches on a side. What's its volume? Well, it'll be 2 by 2 by 2, which is 8 cubic inches, right? Let's enlarge that. 6 inches. What's its volume now? Well, 6 by 6 by 6, which is 216 inches cubed. My ratio of lengths is 2 to 6, or 1 to 3. My ratio of volumes is 8 to 216, or 1 in 27. Not squared anymore, is it? But volume would seem to indicate cube. 1 to the third power is 1. 3 to the third power is 27. So now, if we have a figure that's an enlargement of another and we know its volume, all we need to know is the ratio between one common side. Find a new volume. I'll pause because I realize you guys got a little bit more drawing to do than I do here. So we have this figure that's been enlarged. Let's say this has gone from 8 inches up to 20 inches. And the volume of this one is 512 cubic inches. Let's find this volume. Well, the ratio of lengths is 8 to 20, which will reduce to, both of those are divisible by 4, so 2 to 5. What's that mean for my ratio of volumes? To the third power, what's 2 to the third power? 8. 5 to the third power is 125. So over here, the 512 has to go up there. And then 6,000 what? $8,000? Okay, what is it? What's that? 64,000 right on the head? 6,400 you mean? 64,000? $8,000 right on the head. Forgot to divide by the 8. So 8,000 inches cubed. One for you guys to try in your notes. And let's say that this goes from being 4 feet to being 10 feet. And the surface area of this is, what happened here? 368 square feet. Find the surface area of that one. I'll give you a minute. Surface area is the area of the whole surface. What's our ratio of lengths? 4 to 10, which reduces to 2 over 5. Are we going to cube it? No, because we're looking for surface area. Surface area is an area, so we are squaring it. This will be 4 to 25. $2,300. So that's 2,300 feet squared. Now, what if I told you that this was 440 cubic feet of volume? Now is where we would take the ratio of lengths, the 2 to 5, and we will cube it to get a ratio of volume. It's going to give us an 8 to 125. So now when we cross multiply and divide, we get what? 5750? Perfect. What do you think? Keeps you thinking, huh? Okay, we're going to have a packet that I'm going to hand out. In the first packet, it's going to be page 1. Then there's going to be an additional worksheet that I'm going to hand out, which is going to be that whole page of that worksheet. So I'll hand those out in a second and get you working. For those of you that are going to be here next week, I did cram a little bit extra in here for those of you that are going to be gone. Just extra homework, just so you know.